let's say hypothetically, right, that this is your room, right? This room here belongs to you. Now, I want you to go and store something in this room. So I have another square, which is blue. I have another square, which is green. Okay, so I have two squares here. Now, I want you to put it in your room. Where will you put it? Where will you put it? Will you put it here? Will you put it over here? Will you put it here? Will you put it in the middle? Where would you put it? Who can give me a jump as to where they think they would want to put it? Bernard, do you have an idea? Okay, Bernard is the co-host. Alexander, do you have an idea of where you want to put it?
No, sir.
So he said I should put it in my room.
So again, were you with us from the beginning of the class?
Yes, sir.
I said that the square here, can you see the square I'm moving around?
Yes, yes, yes.
Is your room. Now, I have
Mm-hmm.
two squares. One is green, one is blue, right? I want to place the green square inside my room. Where in the room would you like to put it? Do you want it to be in the top corner here, the bottom corner, the side corner here, or in the middle? Where would you want to put it?
So in the left corner, top.
In the top left corner. So you'd want to put it.
Yes.
Okay, that's fine. That's cool. That's fine. So you want to put it over here.
Yes, sir.
The thing we are putting here, you know the size of it, right? The size is like this. That's why you chose to put it here. Now,
Yes.
I'm going to ask you another question. I want to put something in my room. Where should I put it? Not any of these two things. Something in which I'm going to put there. Where should I put it? Should it be in the top corner the same way as the first one or somewhere else?
Okay, sir. So since the left corner, if I want to arrange,
I've taken it out,
if
so there's nothing there again. So right now you can see there is nothing there. So where should I put the thing? The same top left corner.
yeah, I'll put it there.
Okay. So now I'm going to draw the thing which I'm going to put in the top left-hand corner, right? So this is the thing. Will it go in your room?
So no, it will not go.
That is the first mistake in which we must think of. Now, if let's say I am going to do a party and I came to any of you and I told you that for my party I'm going to do, I need you to store some drinks in your house for me because I don't have space in my fridge. And you told me, okay, because you know I'm your teacher, if you do me good, probably I also do you good. So you say, okay. Then I come to your house with a tipper truck full of drinks. Will it go into your house?
No, sir.
No. So the understanding over here comes from this. The computer has space in which it has to give. The space it has to give is the black. You, the user, have to put information in this space, but the space is finite. If you buy a computer and it is 4 gig, you can't change it. If you want to change it, you have to remove it and go and buy another 8 gig there or 10 gig or 100 gig. You can't change it. It is fixed. So the question here is this: how does the computer know what to put in its space so that the space does not become overwhelmed? Because it is logical. The user is entering stuff. The computer needs to know how big the things are to know where to put it. And if the thing is too big, then it can tell the user what you are bringing is too big, so you can't put it in me. Now, the words that I am using are very important. I'm painting a picture. And the picture in which I'm painting is I want to store the thing, but the computer doesn't know what I want to store. To be honest with you, the computer doesn't care about what I want to store. What I want to store has nothing to do with the computer. The computer couldn't give a damn of what I want to store. So how does he know? And how he knows is by using the word data type. Data type tells the computer how big the thing you want to store is. Is the thing an integer? Is the thing a double? Is the thing a character? Is the thing a floating point number? What do you want to store? So that what you want to store, the computer will say that, the person wants to store an integer. So the place I have to store it should be big enough for an integer. The thing you want to store is a double. So the space I want to create should be big enough for a double. For you, your understanding is integer is int is for integer, double is for decimal numbers, floating point is for decimal numbers, character is for anything which is on your keyboard, which is a character. A, B, C, D, E, F, at all of those things are characters. But to the computer, it means something different. To the computer, it means that the person wants to store an integer. The space I'm going to create should be big enough for the integer. So if I go and type on my computer that int x is equal to 5, and this is the piece of writing in which I have typed that int x is equal to what? 5. This makes so much sense. Int x is equal to 5. But what does it mean? You see, a lot of the time, we forget that programming has a word associated with it, which is programming language, which means it is a language. So we are not here to code. We are here to learn the language. The coding is you speaking the language. So if you don't learn the language, how can you code? Int x is equal to 5. What does it mean? It means that create a space that is big enough to hold an integer and put 5 there. That means when the computer sees this writing here, he is going, or she, or whatever, or it, or whatever you want to term the computer, is going to create a space. When it creates this space, it is going to give this space an address called X. And then in the address called X, it will put 5 there. So this X in which you have over here is the address. This what we have over here, the 5, the 5 itself, this 5 in the middle here is the value. But the place the 5 will be, now let me repeat, the place the 5 will be is what we call the variable. The variable is where we store information. X is not the variable. X is the address which points to the variable. So when we say create a variable, we are telling you create a space to store something. We don't know what it is, but we want to store something. The thing we want to store doesn't matter. It doesn't matter. We just want to store something. But if you are storing something, where are you storing it? How do you get it back? You need a way to get it back. If you go and put money in the bank and you go and say, hey, bank, take my money, and you come back and you say, hey, bank, give me back my money, how do they know you put the money there? They need your account number to know where you put your own money. How much more a computer? You telling a computer, store this for me. Where should I store it? Store it in a place we are calling X. So that if I want my information back, I can tell you, go to the location called X and pick the information back from there. So if I come to my code, so I'm still in VS Code, I'm going to go to the side. I'm going to create a new file. Now I'll call this file main.c. Oh, sorry, we are doing C++. So it's supposed to be main.c++. One second. Okay, so here I want to create a C++ file. So it's going to be main.cpp so that it is a C++ file. Good. Now in here, I need to create my C++ code, right? I can't just go and write the code. I can't just go and write anything there. There are certain things I need to write. What do I need to write? So remember, first thing, create a file, name the file. The first file we'll create will always be main.c++. Don't go and create Kojo main2, main4. No, create a folder. For that folder, your work there should be main.c++. Once I'm done creating the main.c++, I need to create some certain things. All right, some certain codes over there. What do I need to write? I need to include the input-output stream. Why have I done? Why is this important? Why is it that every time we write code, we will have to tell the computer, import input-output stream? Why do I always have to add this piece of line? If I don't add it, will my code run? Why is it important? The include input-output stream has a term. The word describing it is called the preprocessor directive. That is, before your processor can run your program, it needs instructions. So you need to send instructions to it. One of the instructions we are sending is that we are going to be using the input bus. We are going to be using the output bus. So make sure the input bus and the output bus is open for us to use. If you don't bring these two things, it means that your application will not be using the keyboard and will not be using your screen to display items. So they have to be there. Secondly, we need to tell it that there are some words in which is known by C++. So make sure all of those words can be used in this page. That is why we are typing using namespace standard. So using the C++ namespace, which is standard, using the words which are known by the C++ program to compute, make sure we have them. And these two things are your pre-processor directives, which means they'll be sent to the computer that, oh, this program is going to be using the keyboard and the screen. And this program, there'll be some words which are used over there. Make sure you recognize those words that they are C++. If you don't bring these two words, your code will not run. After that, you type int main curly bracket, parenthesis, curly brackets, and then you say return 0. We will discuss this structure very soon when we do functions. But for now, every program you write, this is the structure. When I tell you write a program, this is how you type it first. When you're done with this, then you type anything else. Sometimes it takes a student the entire semester to learn how to type these 4 or 5 lines on the screen. We are not like that. We should not be like that. How will I declare a variable? In your exam, I can say declare a variable of your choice. If I do that, then I've left it open to you. Or I can say declare a variable that is going to declare a variable called number 1. What does that mean? It means that give the variable a data type and give the variable a name. That's all it means. So the name is what? Number 1. So in doing this, I have declared a variable. I have told the computer that, oh, I've created a space, and the space has an address called number 1, and the space that has an address called number 1 is going to store integers, so make sure that is the case. I've declared another variable, I'm calling that number 2, make sure that is the case. I've declared another variable called sum. Make sure that is the case. Now, I can ask you, declare and initialize. That means that when you do int number 3, you have declared. But when you say it is equal to 0, you have given it an initial value. So anytime you give a variable an initial value, you have initialized. So when we say declare, it means create it. To create it, what do you need? You need a data type, and you also need the name. To initialize it, you need to give it a value. So on my screen, I can say sum is equal to number 1 plus number what? 2. That means that now look at this very carefully, because a lot of the time, whenever students are doing programming, they think they are doing maths. Programming is not maths. People who do maths are good at programming because they think systematically. To do programming very well, there is a way you must think. There is a way you must think. And the way you must think is systematically. But that doesn't mean that if you don't know maths, you can't do programming, because programming is not maths. On the screen, we are not saying that sum is the same as number plus number 2. That's not what we are saying there on line 13. On line 13, we are saying that we have a location called number 1. We have a location called number 2. If we add them together, go and put the answer in a location called sum. That's what we are saying on that line. The question then comes in, how do I let you know that we have added number 1 and number 2? Because if I press Control S to save this, and I come over here and I click on run, and my code runs, and my code after running opens in the compiler. See, code is running, checking everything. I have pre-launch. Okay, let me run it from the code run prepare. Good. So if I run it, nothing happens. There's nothing showing here. Nothing will go on. That's cool. Nothing is going on. Okay. Why is nothing going on? Because I haven't told the computer that when you are done calculating, show the user. When you are done calculating, show the user. Show the user. How do we show the user? We will say see out. 2 signs, sum, end it. So when I now go and run it again, run, it will tell me that, oh, sorry, before I go and run, I must save my work. Let me clear my screen here so that everything is clear. And then I'll go and click on the run button again. And it will tell me that my answer is 10623268. Why is it telling me that my answer is 10623208? Why? Because number 1 has nothing there. Number 2 has nothing there. How do I know it has nothing there? Because we have not initialized. We have only declared. What is declare? Creating it. What is initializing? Creating it and putting something in it. So if I want something tangible to show, then I must say this is equal to 5. I must say this over here is equal to 10. So that if I come and I run it again, the computer can take them, calculate, save. So save. Let me click here and then save. Come here, run. And then the computer will tell me that, oh, what I'm doing, it is going to give me an answer of 15. We must learn why things happen. When you're on your own and you type this and it doesn't run, you mustn't panic. You must ask yourself questions. Why didn't it do this? Why didn't it do that? Are there any questions so far? My people, are you there?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Raffle, Raf, Ekuyi.
Yes, sir, we are on it.
Ray, Yeti Asiana.
Yes, sir. We are. I'm understanding it.
Let's go through some slides and see what we are talking about. What is a data type? A data type tells the compiler what kind of value a variable holds and how that value should be stored and utilized. On the screen, you can see that we have some examples of data types. We have int students, which is equal to 240. When we say something is an integer, as I've said, it means that thing will hold integer values, 1, 2, 3, up to a billion, and then the negatives. Double means that that thing is a decimal. Char means that that thing is a character. So we have A, B, C, D, so on and so forth. And Boolean means it is either true or false. When we say a data type is primitive, it means it came with the computer. When a computer was built, they added it. So the primitive data types in which we have are int, short, long, long, float, double, long, double, char, wk, boolean, and void. Derived means that it was built by other people, where we have arrays, pointers, references, and functions. Then we have the user-defined data types, which are the construct, classes, union, enum class, and typed definition using. We will learn most of these things before the end of our course. Integers are this size. So anytime you use an integer, means 4 bytes of your memory is gone. Floating point numbers are this size. So anytime you use a float, you use 4 gig, and 4 bytes. Anytime you use a double, you are using 8 bytes. So you must be very careful of which one you pick. And remember, floating point numbers are all decimals. So when do you use a float? When do you use a double? I will use a float when the decimal points behind my number are 6 to 8. And I'll use a double when I want 16 decimal points behind my number. Characters are literals. A, B, C, D, E, F, number, slash, N, all of those things are characters. Booleans are numbers which are true or false. So anytime I want to do something which is either going to be true or false, then I will have a Boolean. Modifiers allows you to do signed and unsigned numbers. If a number is signed, it means that it has a positive number. If it's unsigned, it is negative, things like that. Very important. Now, in all of this, I've mentioned that the variable, this here, is the address. How do I write the address? The address must always start with a number. It can never start with a character. Oh, sorry. The address must always start with a letter. It can never start with a number or a character or a space. The address can have a number in it. For example, on the screen, I have number 1, number 2, but it can't be 1 number, 2 number. It can't be that. And it must describe what we are talking about. it must describe it. Let's have some examples. Let's have some examples. The class rep, what time do we close? Just so that I don't go over your time. Because I know you have another lecture after.
5:15.
5:15. All right, sure. I would love some honorable person to read for me. Okay? Somebody here who is honorable and God will bless him this week should read what is on the screen for me. There's no honorable person in your class?
Sir,
Oh, read it for me.
okay. There are 3 sitting categories at the stadium. For a softball game, Class A seats cost $15, Class B seats cost $12, and Class C seats cost $9. Write a program that asks how many tickets for each class of seats were sold, then displays the amount of income generated from the ticket sales.
Wow. Perfect reading. Perfect reading. Anybody here, before I start calling people at random, wants to take a stab at explaining the question to us? In your own words, what does the question say? Or what do they want us to do? That's a better question. What do they want us to do? The silence is good. As always, we have to do it the colloquial way of calling people one by one. So let's start calling. Emmanuel, what is the problem they want us to solve?
All right, sir. Sir, good evening.
Good evening.
Yes, sir. Sir, from what my colleague has read, my understanding is that they are trying, or the whole script is trying to let us understand that we have to devise a means or a system that will capture the various sections of the seats that will be sold, and then the amount will be made at the end of the program.
Okay. If, let's say, your sister's child came to you and said, oh, Wafa, we almost per se a day. In one sentence, what do they want us to do?
Okay, sir, so they want us to...
No, one sentence. So, they want us to
devise a means.
Prepare a sheet.
prepare a sheet. Did you say prepare a sheet?
Yes, sir.
What sheet?
Excel sheet.
Hello, sir.
And a question the
Sir.
Excel one. I mean, who needs
Sir.
Excel one? Yes.
Sir.
Yes.
Sir.
Yes. Yes.
So they want to know how much ticket was sold per seat.
Is that what they want? Is that what they want?
In one sentence.
Is that what I'm asking? Is that what they want?
So they want an account.
Is that what they want? Look at the screen. Look at what I've highlighted. Is that what they want?
They want
Sir,
they want their profit. They want the profit.
Is it the profit they want?
Sir, they want to know the income that is generated from.
That is what they want. They want to know the income generated. That is what they want. You see, a lot of the time, when we are starting to learn coding, this aspect of it goes away. But as engineers, as people who are scientific, If you don't know the requirements of a user, you will suffer. The user's requirements are very, very important. The user's requirements are very important. Whenever you're in class and you're doing this coding stuff, the questions are here, then you read it to write a program to do this. If you go to the marketplace and someone tells you that, oh, I sell rubber bags for people to sell. The black rubber bags, the white rubber bags they use for kinky, all of those things, that is what I sell. Now, they steal from me a lot. So I want you to design a system so that when the person comes, I can let him pay for the rubber. He'll get a ticket, then he'll go to another place and then using the ticket, get the rubber he's looking for. What does the person want? If you can't answer that question, whatever you develop for the person will be wrong. Understanding the question is the solution. The moment you can't understand the question, you have failed. Not in this course, because this course is irrelevant, but as a programmer, as a developer, as a constructor, as a builder, if you can't understand the requirements of your user, you have failed. In this question, what do they want? They want to know the income generated from sales. Full stop. You knowing that they want to derive the income generated from sales. You knowing that the problem they have, the only problem they have, is that they want you to compute the income generated from sales. The next question that comes in your mind is, how do I get the income generated from sales? Because if you don't know what you want, how do you mobilize yourself to get to what you want? How do you do that? I hope you all understand. So now that I know that this is what they want, the question comes in, at the end of the day, what am I supposed to show them? I'm supposed to show them the income generated. Full stop. Because that's what they want. So at the end of the day, if I can't show them the income generated, me as a developer, I have failed. What do I need to get to the income generated? I need to know the number of seats that they have. So I need to know Class A seats, Class B seats, Class C seats. I need to know that. If I don't know that, how can I give them the income generated? But if I know this and I know this, how do I get from this to this? I will have to calculate it. And in calculating it, this is what I am going to calculate. Now, programming is step by step. So if I have the income, it is equal to seat A times 15, seat B times 12, and seat C times 9. How do I get there? How do I get there? I'll get there by starting. I will declare the variables A, B, C, and income. I will let the user enter A, B, C. I will calculate seat A times 15, seat B times 12, and seat C times 9. Whatever answer I get, I will display it to the user. We must start thinking like this. Our thinking must be like this. Your thinking must now be in steps. There are no more general statements. Every statement you make must be precise and concise. Everything you do must follow a particular pattern, and that pattern must be precise, concise as to what you do. There should be no errors in your voicing, no mistake in what you analyze. So if I was asked to turn this into code, I will start off with my structure. This is my structure. My structure will never change. They said I have to declare the variables for the seating positions. So seat A, seats. I can't just declare it like seat A, seat B, you see. Then here's where I come, seat C. It's wrong. The computer is underlining it for me. Because we have learned today that to declare a variable, I must add the data type. Do I use double? Can you buy 2.5 seats? No. So all my seats have to be integer because they are whole numbers. You can buy 1 seat, 2 seat, 3 seat, 4 seat. Because today we are not doing inputting today, and we'll do it next week. In here, I'll say the total number of seat A seats are 100, the number of seat B seats are 200, and the popular stand will always be plenty. So that one is what? 500. And we are saying that for me, I will also need a variable for my income, and my income will be a double. Why is my income a double? Why didn't I say the income should also be an integer? Because all of us here, when we are paid, we are not paid as a whole number, but they are coins. And the coins is the integer. So if I save it as an integer, what happens to the coins? They go away. So I am thinking of that. Then I can come and say income is equal to seat A seats times 15 plus seat B seats times 12 plus seat C seats times 9. Every statement ends with a semicolon. Look at how I type. Look at how I am explaining every line to you. Why am I doing it? And every line proceeds to the next line. Now, at this stage, I have calculated the number of seats I have. Hence, I can now say that go and display to the user the seats, the income is income. So that when I run my code, it will tell me that the income for them selling the seats is 8,400 over here. Ladies and gentlemen, these are the things we'll be doing this semester. When we arrive here next week, we are going to learn how to input data into our system. And we'll take a series of questions and solve the questions one after the other. All the questions will be in passage form, and we'll have to analyze the question, break the questions down, and solve them. Because in the real world, the questions will be in passage form. So we will learn from passage form. As I always told you last week, it is very important we practice. What we have done this week, when you guys get a class video, at least what we have done this week, go over them and practice. Don't wait till next week. It will become very difficult very quickly. Remember, it is a programming language. The same way when you see someone in town saying, "I dey go camp, I dey camp go," those kind of words, and you laugh at them because wigba. That is the same way where sometimes when you write code, wigba, you must learn the structure, when to bring the semicolon, when not, when to bring the comma, when not, when does the comma come, when shouldn't the comma come. All of those things are things that you should revise on. As always, I thank you all for coming, and we'll end the class here so that you can prepare for your next one. And then we'll meet next week where we'll solve 5 different passage questions and take it from there. Philip, is there a question?
Yes, sir. You said you give us the guideline to install the C++.
Yes. Your class rep should have reminded me. This week was a week that I will never forget. It was busy. I completely forgot until he called me this afternoon. So the moment the class ends, I will start sending you all of those things. Is that okay?
Yes, sir. Yes, sir.
Again, thank you all for coming. Have a wonderful weekend and good luck. Bye-bye.
Bye-bye, sir.
Bye, sir. Thank you very much.
We close.
Close.
Close like that.
Why? Who close you?
Senior, beg, go take the thing, make you download the thing. Then we use it to play.
Charlie, they make we go meet for our group, our WhatsApp group talk.
Okay.
Go outside.
Fine. That guy is out.